Okay, here's a video. I'm going to be teaching some of the solutions for the practice test that I put out for regular physics class today. Maybe not all, but we'll just see how it goes. A naughty student came up with the following equation to figure out the velocity of the box after it slides down a ramp. So if you're just picturing this, it's basically what's the velocity at the end is what they're trying to get at here. So what's wrong with the equation? So this question requires that you understand how equations work and how to solve it. If you have no idea how to solve this problem on your own, then you would have no idea what's wrong with this equation. So the first thing you do when you come across a question like this is identify what are these terms. There's three terms here. Try to identify what they are. MGH is potential energy. 1/2 mv squared is kinetic energy. Mu sub k mg, is the force due to friction on a flat surface. Okay. And here, so the equation they're trying to do is potential energy of a system minus the force of friction on a flat surface equals Ke. So there are a couple things wrong here. Let's just start with the obvious. This is not a flat surface. This is a ramp. So the force of friction on a ramp is mu sub k mg cos theta. So that's the first thing that's wrong with this problem. However, that's not the only thing that's wrong with this problem. This is an energy, this is an energy, this cannot be, you can't subtract a force from energy. I mean, you just dimensionally, you can't do it. You can't have joules here, and then expect that you're going to subtract off newtons. It just doesn't make any sense. So we need to be subtracting off the work due to friction. So the work due to friction is mu sub k mg cos theta d. The d is what makes it work, no pun intended. So there's two things wrong with this, which is why it's worth 2 points on last year's test. The problem is that it's on a ramp. So force due to friction is mu sub k mg cos theta. And we need work, and that is mu sub k mg cos theta d. All right, that's the problem. This is what belongs there. And again, if you haven't been doing your homework and you haven't been paying attention, that you might not realize what's wrong with this term right here. But for those of you that are caught up, you hopefully should see that right away. Okay. 2 Nazi bullets are fired from different guns. Bullet B has 1/3 the mass and 1.75 times the velocity as bullet A. Bullet B has blank times the kinetic energy upon impact. Show the work. Okay, so these are pretty common questions that I like to ask because it gets to sort of the relative differences between, or let me rephrase that. It gets to how does the mass and how does the velocity affect the overall kinetic energy of a system. So if we think of bullet A and bullet B, so we'll say the Ke of A and the Ke of B. The Ke of the Ke of A is the thing that's not adjusted, right? Because the bullet B is always 1/3 of the mass and 1.75 times the velocity. So bullet A is sort of like the unadjusted one. So that's just simply going to be 1/2 m times v squared. However, bullet B is the one that's being adjusted here. It's got 1/3 of the mass, and it's got 1.75 times the V. And so this whole thing is squared. Important. It's not just V squared. It's the 1.75 is also squared. Okay, so you're trying to figure out what the overall effect here is. The easiest way to do that, the easiest way to do this is to plug in some numbers and then just check the overall effect. The best way to do this is to make every variable that you don't really know to be 1. So for example, the kinetic energy of A is just going to be 1/2 times 1 times 1 squared. Okay? Because we don't know what the velocity is. The kinetic energy of B is just going to be 1/2 times 1/3 times 1.75 times 1 squared. you're comparing these two values. So the halves will go away. They're going to cancel each other out. So really what you're doing is the difference between these two kinetic energies is whatever 1.75 squared is times a third, because this is all just 1. So 1.75 squared divided by 3, that's the 3 right there, and that is going to be 1.75 squared divided by 3, 1.02. So bullet B will have 1.02 times the kinetic energy of A. And that is the way you do it. You just simply put in these values here into the formula and then just solve it. Okay? Question 3, a terminally ill but nice elf is dropped from a height h. Later, an identical elf is dropped from a third of that height. How much more Ke does this? So this is a similar question, except that now it's about potential energy converting into kinetic energy. So how much more kinetic energy does the first elf have upon impact with the ground? So we have some elf being dropped from some height. We have another elf being dropped from only h divided by 3, because it's a third of the height. So how much more kinetic energy does the first elf have? Okay, so the first thing to realize here is that all the potential energy is going to turn into Ke. Potential energy is mgh. The first elf here has 3 times the height of this elf here, so it has 3 times the h. So it's going to have 3 times the potential energy, right? If this guy up here has 3 times the potential energy, it's going to have 3 times the kinetic energy on impact. So the first part is 3 times the Ke. How much faster was it moving? Remember that Ke is equal to 1/2 mv squared. The masses of the elves are the same. The half is the same on both formulas. So the difference in the kinetic energy is really just this factor of 3 squared. It says how much faster was it moving? So if we have 3 times the Ke, and this stuff is all consistent. Like the half is the same on both elves. The m is going to be the same on both elves because it's the identical elf. The effect of the velocity is, take the square root of both sides. So square root of 3 is equal to v. So what is the square root of 3? It's 1.73. Again, so the final answer here is that the first elf is going to hit the ground with 1.73 times the velocity. Why? Because it has 3 times the kinetic energy, and the kinetic energy is proportional to v squared. So v must be proportional to the square root of the Ke. So 1 point, and again, you could have done made up values and just actually crank this out if you wanted to. You get the exact same answer I do. This is just the better way to do it. It's faster. It's more simple. So 1.73 times. This is the last one I'm going to do on this first video. A new type of engine provides 3 times the power of the previous model. If the previous engine could lift 90,000 kilograms of elf droppings, a vertical distance of 30 meters in 30 seconds, how long would it take the newer model to lift the same mass of elf droppings in the same distance? Okay, power. Remember that power is equal to work divided by time, which is the same thing as FD divided by time. So it provides 3 times the power. The previous engine, so let's just say P original for O. The previous engine could do 90,000 kilograms. Remember now the force has got to be the weight, so it's mg, so it's going to be 90,000 times mg. So this is the mg. And it could do it at a distance of 30 meters, and it could do it in a time of 30 seconds. Okay. So this is the power output of the first engine. So 90,000 times 9.8 times 30, and I'm going to divide all that by 30. And this is 882,000 watts. The previous, the new engine is 3 times the power. So there's a couple ways you could do this. It's asking it to lift the same mass, the same distance. So we're going to be keeping the M, G, and D the same, but we do it. We have 3 times the power. Again, if we're going to be doing this, if we have to keep the force the same and we have to keep the distance the same, but we have 3 times the power, in order to keep this proportional, to keep this equation correctly, you have to reduce this number by 1/3. So if it's going to have the exact same mass, the exact same distance, but it has 3 times the power, it's only going to take 1/3 of the time. So this is going to take 10 seconds. You could actually crank it out. You could actually crank this out if you wanted to. You could go 882,000 times 3, set it equal to 90,000. I mean, you could do it this way if you wanted to. It just takes a long time. You get the same answer. All right, that's it for this video.